Can science predict how attractive you are? Take a look at these faces. Who do you find most attractive? Most people choose this face. Why? Well, this one happens to be the average of these 7 faces. Research has shown that we find average faces more attractive. In fact, the more faces you use to create the average, the more attractive it is. How does your brain calculate an ideal average face? Let's take a look. Faces, like any image, are made up of lots of little pixels. One way to compare faces is to compare corresponding pixels. If the corresponding pixels are similar, the faces are similar. The properties of each pixel vary. For example, we can look at brightness. We can also look at saturation. Watch as the color purple desaturates. Let's now take the example of hue. A pixel's hue can be represented by a number. Since a face is made up of pixels, and pixels can be represented by numbers, a face can be represented by a series of numbers. You can use these numbers to plot points in a multidimensional space. For 2 numbers, you need 2 dimensions. For 3 numbers, you need 3 dimensions. Since we need many numbers to represent all the pixels of a face, we plot faces in a multidimensional space. This requires so many dimensions that we can't even visualize them. Although we can only imagine this space, we can think of the similarity between 2 faces as the distance between them in the multidimensional space. What about the average of the 2 faces? Well, you can think of it as the midpoint between these faces in space. We see lots of new faces every day, definitely more than 2. So how does your brain create an average of all of these faces? One possibility is that the brain stores every single face you see in your memory. Say you're walking down the street and see a stranger. Your brain could add that face to its collection of stored faces and compute an average using all of the faces you've ever seen. This is a lot of information for your brain to remember. We may not need to refer to every single face we've ever encountered. Perhaps the brain instead stores a running average, which it updates every time it encounters a new face. With this method, new faces are no longer stored in a collection. Instead, when we encounter a new face, the average face is updated. We don't have to compute an average from thousands of faces. We can instead compute how the average changes, based on how many faces we've seen and how the new face compares to our current average. That means we can store a much smaller amount of information in our memory. When we encounter a new face, we compare it to the average face. The closer it is to the average, the more attractive it is. So the next time your friend says, "Wow, that person is really hot," you can reply, "Meh, they're just average."